A very good morning, children. In the previous session, we had learned about amines and we had learned the previous year's questions also from the topic of amines. Some children had raised this point. Sir, we can read the topics that are taught in the classroom session. But in one section, like CT, polymers is taught. But in NEET section, I think only one class was done. So, just in view of that point, I have taken this concept is called polymers. We cannot complete on a single period. We will try to do in 2 periods. Most probably today is Saturday, right? So today's session I may complete half and remaining half on Monday section I will take, and we will be having a question hour round also on this topic called polymers. So I will not give the definitions here. We will see what is the main title that is necessary, and orally I will give the statements or something, then I will give the examples for that particular concept. Okay, children? And the reactions that are taking place in this concept and what are the conditions under which the reaction is taking place will be discussed. Done. Now coming to the topic called polymers. Polymers. Actually here everyone knows poly means many. Poly means many. Mer means repeating unit. Mer means repeating unit. So this repeating unit, we are giving one more term that is called as a monomer. What is the term called as a monomer? Repeating unit, what is the one repeating? We call as the monomer. For example, we are having CH2 double bond CH2. CH2 double bond CH2. What do we call this one as an ethene? This is called as an ethene. So this ethene molecules, we know polythene covers, right? So how the polythene cover is obtained? How is the polythene cover is obtained? The ethene molecules, many they will take, not one or two, they will take many number of ethene molecules, more number of ethene molecules, more number of ethene molecules, many number of ethene molecules were reacted under some conditions. 1000 to 200,000 atmospheric pressure, 1000 to 2000 atmospheric pressure, and a temperature of 350 to 570 Kelvin, and a temperature of 350 to 570 Kelvin. In the presence of free oxygen, or peroxide, this is acting as a catalyst. The ethane molecules will be added with one another. See here, the double bond is there now. The double bond will be shared to one of the molecule, and the next one will be followed to the next molecule. So between these ethane molecules, the double bond is being shared by the molecules. So the same molecule will be repeating n times, many number of times, up to 10 to the power of 3 to 10 to the power of 7 mu at molecular mass they will have. The mass of the formed compound will be around 10 to the power of 3 to 10 to the power of 7 mu. So this process of combining many monomers to give a polymer, we call the process as polymerization. What is the process called, children? The process is called as the polymerization. See here, in this only the pi bond electrons were donated for the next carbon. So what type of bonding is observed here between carbon and carbon? Don't forget the bonding is only covalent bonding. The covalent bonding is only covalent bonding. So the formed polymer may contain covalent bonds in few examples like this. In some other examples they may have hydrogen bonding. Okay, so the bonding will be different, but it may be covalent bonding or hydrogen bonding. See, in this kind of formation of a polymer from the monomer, we did not remove any atoms. simply between the monomers addition has taken place. Addition has taken place. So this polymerization, the polymerization that we are learning presently, it is mainly classified into two types. What is meant by polymerization? The process of forming a polymer from the same monomers or different monomers. Here I had used the same monomers. You can use different monomers also. When you are using same monomers or different monomers, if they are combining with each other, and such kind of polymerization is called as an addition polymerization. What is such kind of polymerization called as the addition polymerization? Such kind of polymerization is called as the addition polymerization. But during some polymerization process, some atoms will be removed, neutral atoms will be removed. Those polymerization will be called as the condensation polymerization. What is that called as the condensation polymerization? See here generally we are going to highlight this polymerization process presently. Presently we are going to see how many types of polymerizations are there. We had already seen addition polymerization is there, condensation polymerization is there. During this addition polymerization, the chain will be increasing. So this addition polymerization is also called as the chain growth polymerization. What is this one also called as the chain growth polymerization? Usually for us it appears like it is a single step. Is it not, children? But this is not a single step. Addition polymerization is not a single step. It takes place under the presence of a peroxide catalyst. Under whose catalyst is such step? It takes place under the presence of a peroxide catalyst. Peroxide means what? See, this process of addition polymerization. Once we are studying how do this process of addition polymerization takes place. Let me erase the board. Process of addition polymerization. How is it taking place? How is this process of addition polymerization takes place? Addition polymerization process. How is this taking place? Initially we said it is taking place in the presence of peroxide. So the first step is chain initiation. What is called as the chain initiation? What is meant by chain initiation? Let us see one example. C6H5, C double bonded O, C double bonded O, C6H5. It is called as a name benzoyl peroxide. What is the name of this function line? It is called as the word benzoyl peroxide. Generally, peroxides are unstable in the presence of sunlight. Unstable in the presence of the sunlight means the bond will be breaking at the peroxyl case, and then there will be a free radical that is generated. What is generated, children? Free radical is generated. When do the free radical generates? When there is a homolytic cleavage. Free radical is generated due to the homolytic cleavage at the peroxy bond. So this free radical that is generated 2 moles I am saying because the 2 repeating units will be there. No? So these 2 repeating units will undergo further homolytic cleavage at this point. So they generate 2 molecules of phenyl radicals. 2 molecules of the phenyl radicals, and carbon dioxide gas is removed. So in chain initiation, first thing is from the peroxide some free radical was generated. Phenyl free radical was generated. The generated phenyl free radical will start reacting with the ethene molecule. Breaking its one of the pi bond as a homolytic cleavage, resulting a bond between the phenyl group and the CH2 linkage group. So the free radical was initiated on our actual reactant. And then this formed intermediate will undergo chain propagation step. What is this one undergoing? Chain propagation step. Chain propagation means we know continuous growth in chain is called as the chain propagation. So C6H5CH2 radical, the one that is formed, it is next reacting with another ethene molecule, forming C6H5CH2 with this part is there now. It is bonding and breaking the pi bond here and forming CH2. Let us imagine here n number of molecules are there. So here I am saying n number of molecules will be forming the chain. Means the chain growth takes place. So that's what we call as chain propagation. At last, it is concluding with chain termination. Means Means what, children? If you bring another molecule of this type, see here, at last carbon there will be free radical. Now, what I am imagining is, this is one of the molecule, and I am bringing another such type of molecule here, like C6H5CH2. Means instead of writing a step again, what I am thinking in the chain termination, two similar molecules. This is molecule and another molecule. They may combine with each other. So when they are combining, imagine this CH2 part. Many CH2s are repeating. So what I want to conclude, like here one C6H5 is there and CH2 in cases are repeating. I can simply write this one as N. At last one more C6H5 is there. Means this is starting, this is ending. In between many CH2s are there. What we thought, it is a direct step. But how many substeps are there? 3 steps are there. So this addition polymerization mainly takes place under the chain initiation step, where a peroxide free radical will be breaking the presence of sunlight, generating a free radical which will be reacting with the actual reactant, and it propagates the chain. At last, two similar molecules will combine with each other to terminate the chain process. So this is how the addition polymerization generally takes place. Now let us see some of the addition polymers. Some examples for the addition polymers. Some examples we can take. Examples for addition polymers. So here, the first thing what we are starting is with the polyethylene. The first thing that is started is with the polyethylene. This polyethylene, for example, when you are traveling, you will have water bottles with you. You can squeeze that water bottle. But can you squeeze dustbin? Both are made of plastic only, But water bottle we can squeeze down, but dustbin we cannot squeeze. The reason is, water bottle is made of some kind of plastic that is not tough. Means we can say that is flexible. For example, when we are winding or when we are joining the wires, we will apply plaster. That is also polythene only, but it is not very rigid. It is somewhat soft. Such kind of polythene we call as a low density polythene. What do we call as the low density polythene? It is generally represented as the LDP. How is it prepared? Its preparation is involved like ethene molecules were reacted. Already we brought this point, you remember, I think so. 1000 to 2000 atmospheric pressure at a temperature of 350 to 570 Kelvin. This is temperature Kelvin. In the presence of free oxygen or a peroxide catalyst. Here in the JE means this catalyst will be pointed out. to give low density polythene. To give low density polythene. This is somewhat nature. If you see its nature, it's soft, flexible, has used in the preparation of water bottles or plasters. Here we are having the next kind of polythene that is called as the high density polythene. What is it called as the high density polythene? High density polythene, it is somewhat tough, means stronger than the low density polymer. Stronger than low density polythene. Low density polythene. Method is used in manufacturing of dustbins and the strong bottles also will be there that are somewhat strong. Now here how it is formed? It is formed by reacting ethene under the presence of a catalyst called Ziegler-Natta catalyst. By using of this catalyst, what is Ziegler-Natta catalyst? Triethyl aluminum and titanium tetrachloride combination. These two combinations will give the Ziegler-Natta catalyst. By uses of this, you can bring a very low pressure. Pressure is very reduced. 6 to 7 bar atmospheric pressure you can take, or you can use at 330 to 343 Kelvin. Very low temperature. By using of the catalyst, pressure is reduced and temperature is also reduced. Very important name of the catalyst for veins. But this, what type of polymer we can form tonight? High density polythene. You can form the high density polythene. So under polythene, two types are there: low density polythene and the high density polythene. After this polythene, we are able to see that in this all addition reaction takes place. Means they will combine with each other to form the polymer. After this polythene, we are having under the same addition polymers. The second example as Teflon. Second example is Teflon. What is meant by Teflon, children? Teflon is also called as tetrafluoroethene. Means what? CF2 double bond CF2. Like ethene only. It is like ethene, but in the place of hydrogens we have the fluorines. So let us imagine two of them are combining, or many of them will be combining to form a repeating unit. Of this kind. So this is called it is simply called tetrafluoroethene. It is called polytetrafluoroethene. You can see your non-stick cookware that is coated with this Teflon. Non-stick, it makes the surface non-stick. Here we can use persulfate as catalyst. What are the catalysts that we use here? Persulfate. Good. The third one is called acrylonitrile. Third one is called as the acrylonitrile. Please observe, children, up to now what type of addition polymerization examples we had learned? Their monomers are of same type. Here also we are all observing the same point. What is the same point? Repeating monomers that are of same kind are repeating. Acrylonitrile. Now here CH2 double bond CHCl. The modifications we are bringing in ethene. That is called the main point to observe. Here it is called as the nitrile, ethene nitrile. If many of these molecules are going for the process of polymerization, are being polymerized, you can say they are being polymerized in the presence of peroxide catalyst. In the presence of the peroxide catalyst, they will be forming polyacrylonitrile. Polyacrylonitrile. This is being used as a substituent for wool. This is being used as the substituent for wool. In the place of wool, we will use this polyacrylonitrile. So these are some of the examples for the addition polymerization. So let us see now, during the polymerization, what will happen or what is called when some molecules are being removed during the course of the reaction. Shall we see? Yes, very good. We are going to see the next type of polymerization, that is called as the condensation polymerization. What is the one called, children? Condensation polymerization. Let us see here the second type of polymerization, condensation polymerization. Okay, it's 20 minutes. I hope we can do this in 2 sessions. One session is not possible, right? Condensation polymerization. Condensation polymerization. Condensation polymerization means what? Condensation polymerization means what? For example, let me take one example that will be clear for you. CH2, OH and OH. It is called as the word ethylene glycol. It is called with the name ethylene glycol. And it is being reacted with a reactant called C double bonded OH and C double bonded OH. We know this one as the terphthalic acid. What is the name of this one, children? Terphthalic acid. When these two are reacted in the presence of zinc acetate, and antimony trichloride or antimony trioxide. These two are acting as the catalyst. What will happen here means a neutral molecule of H2O will be removed. So the polymerization process that is involved, in which neutral molecules are removed. The neutral molecule may be H2O or NH3. This takes place in one example. This goes in one example. In this example, presently what was removed? Water molecule was removed. But if I take n number of molecules, then what will be formed, children, here? See here, hydrogen is being eliminated to this side. That side also hydrogen will be eliminated. Then that is forming CH2, O and C double bonded O. Here C double bonded O is there. Here the OH will be removed with another molecule. This is the repeating unit. See, from this side OH is removed. Means from that side also OH will be removed with the next another molecule. From this side hydrogen is removed. So in the front part another molecule will come up for the condensation. From there the hydrogen will be removed. After lossing, then I draw the structure. It's called tellene or dacron. What is it called as the tellene or dacron? So this is one of the examples that was given here. How many number of water molecules are removed? N number of water molecules are removed as the byproduct. Our pointing out is polymerization, in which some neutral molecules are removed, that are called as the condensation polymerization. See here, children, can you please find out one pointing out thing is here. This is the main thing I want to find. Do you remember R, O, C double bonded O, R? What are the functional group compounds called as the esters or esters? Esters or esters. So during the condensation polymerization, the formed polymer will have the functional groups that are different from the reactants. So here the condensation polymerization is involved in formation of many functional groups. One of the functional group that we are seeing here is called as the polyesters. If I change my example, like I would like to take another example like CH2, 6 NH2 and NH2. Its name is called hexamethylene diamine. What is this called, children? Hexamethylene diamine. Hexa means 6. Methylene groups are repeating. Amides are 2 in number. So this is called hexamethylene diamine. It is going to be reacted with adipic acid. What is that going to be reacted with? The adipic acid. CH2, C double bonded OH and C double bonded OH. CH2s are repeating here. It is called as the adipic acid. Now, in this study here, also the same story takes place. NH2 I am writing here as hydrogen and another hydrogen. Here hydrogen and OH is being removed. So the story takes place between many of the monomers. So see here, as from the hydrogen is removed, from the another term, here also the hydrogen is removed by the OH of the before molecule. Then what is being formed, children? NH, CH2, 6 NH and C double bonded O, CH2, 4 in number, C double bonded O up to nth number that will form. And now what is the functional group in this one? Imagine this is R, this is NH and this is C double bonded O, this is R. Do you remember the functional group amides and then amides? So in the above example we got esters. So I brought that is under the title called polyesters, but this is called under the title called polyamides. Under polyamides, the first example, the name of this product is called nylon 6,6. You will be using toothbrush. The bristles of the toothbrush are made of this nylon 6,6. These are somewhat soft in nature and these are used in the manufacturing of fabrics also. So users, you please read from the textbook. Here short of time explaining only the preparation and the names of the reactant. So under polyamides, the first example that we had learned is regarding nylon 6,6. So let us see one more example under this condensation polymers. Still which is under polyamides only. That's what I am going to call as caprolactam. I will call them as the caprolactam. So under condensation polymerization, the second type what we had learned, polyamides. Under polyamides, the second example is caprolactam. What is caprolactam? It is a 7-member ring, children. NH, C double bonded O, CH2, CH2. This is what the initial reactant. On heating this, followed by reaction with water. The cyclic structure will break at this amide linkage. Will break at this amide linkage, forming NH. See, CH2, 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 CH2. How many are there? 5 are there. CH2s are 5 in number. C double bond in O. C double bond in O. N number of molecules. Here how many will be used? N number of molecules will be used. So N number of products will be formed, resulting the compound called nylon 6. Nylon 6. This is used for the manufacturing of ropes for the parachutes. Ropes for the parachutes. So it is having very strong feature. It's having very strong feature that is used in wide range of applications. Now we have seen the polymerization under the second example called polyamides. Let's see one more. Let us see here about the third polyamide. Third condensation polymerization. The third one we are calling as phenol formaldehyde. Phenol formaldehyde resin. Phenol formaldehyde resin. See children, now once we observe our switchboards, the electrical switches, they are hard because they are made of a polymer called bakelite. What are they made of a polymer called? Bakelite. Bakelite. This bakelite especially, it comes under a type of polymer called thermosetting polymer. Thermosetting polymer. There are mainly two types of polymers, thermoplastic polymers and thermosetting polymers. Thermoplastic polymers means, for example, if you heat them, they will be melting, and if you cool them, they will be solidified. Means you can mold into different shapes. You can see the plastic water bottles at the below. There will be one symbol here showing it is a recycled for 6 times or 7 times. Means they are molded many times. 6 times they have molded. Means that is called under the thermoplastic type of polymer. But some kind of plastics are there, like switchboards or electric boards, which are very hard. Once it is formed, means once it is settled, you cannot remold it. Such kind of plastic we are calling as a thermosetting polymer. It is called as a thermosetting polymer. Means if you heat it again, it will be solidifying, but it will not be changing into liquid state, or it will not be melted. So such kind what we call it thermosetting polymer. Our switchboards we suggested was bakelite. Bakelite is the other name for this one, for the phenol formaldehyde resin. Phenol, we know the formula OH. If you react this phenol with formaldehyde in the presence of HCl, in the presence of the HCl, hydrochloric acid, this acidic medium, the formaldehyde will be bonded with the ortho portion. Formaldehyde will be bonded at the ortho portion. CH2OH. CH2OH. What is the importance of this intermediate that is formed here? This intermediate that is formed in this reaction will undergo side chain polymerization. What is it undergoing? Side chain polymerization. Side chain polymerization means if another molecule of this type is brought near the first molecule, see here one hydrogen will be there. For this one also one hydrogen will be there. Although we had CH2OH, ortho dash we had hydrogen. The hydrogen and OH, the hydrogen and the OH between the molecules, they will be removed. They will be removed as a neutral molecule. By this what is happening? Means the left side some polymer is forming, goes there up to nth number. The CH2 linkage is connecting next molecule. CH2 linkage is connecting the next molecule. So this type of polymerization takes place up to nth number. So the side chain polymerization of the intermediate form, it is being called as the novel act. What is that called as the novel act? That is used in the paints. That is used in the paints as a main ingredient. We can see if instead of taking side chain polymerization, the polymerization takes place at the branching. For the intermediate, polymerization takes place at the branching. Then the final compound form we will be calling as a bakelite. We will be calling as a bakelite. So that's what is short example explanation regarding phenol formaldehyde resin under the condensation polymerization. Under the condensation polymerization. At times when you are so serious, when your mom scolds you, what will you do? You will simply break down the cups that are present in the kitchen. But not to break the cups. At times you cannot break them. So they are called as the unbreakable crockery. Unbreakable crockery. How to prepare this unbreakable crockery means that is prepared using the fourth kind called melamine polymer. Melamine polymer. Melamine polymer means what? It appears like a benzene ring, children. Alternatively, nitrogens are there. What are they? Nitrogens are present. Pi bonds are also present. But here NH2 is present. The reactant name, it is called as the melamine. Melamine. This melamine also we are reacting this one with the formaldehyde. We are reacting this with the formaldehyde. So it is forming some intermediate. It is forming some intermediate. The nitrogen that is present to the carbon side chain will be involved in the bonding. Will be involved in the bonding like NH, CH2OH. It is forming NHCH2OH. So the one that is formed here, if you take them in N number, they will undergo the process of polymerization. They will undergo the process of polymerization. Means how here I am saying another molecule is there of this type. Up to here step 1 is completed. Step 1 is completed. I am imagining step 2. From here this is the step 2. So this will be combining with another molecule. Combining with another molecule of the same type. NHCH2OH. Here what is there? NH is there. NH2 is there. Here what is there? NH2 is there. Right. So the OH will be removed with one of the hydrogen. OH will be removed with one of the hydrogen. So there will be a bonding. There will be a bonding forming the melamine polymer. Forming the melamine polymer. See here the formed polymer will be like this. Melamine. These all structures are also important, children. You must study the structures also. NH2, CH2, NH2, CH2. Here NH2 will be there. Here also NH will be there. So this is our nth number. This is forming up to nth number. That's what we are calling this one as a melamine polymer. It is called as the melamine polymer used to prepare the unbreakable crockery. Up to here we have learned about our different condensation polymerization examples. And the next important point we need to go is with the rubber. We need to go with the rubber. We cannot conclude the rubber in a single point. So I am stopping here. Your work is to read textbook. Line to line you must read. After reading the textbook, then we can bring the MCQs based on these topics. So the topics that are still left over are, we will deal with the rubber and we will deal what is called as a copolymer. Copolymer. Then we will deal the types of rubber. Then synthetic rubber and biodegradable rubbers we will see. Later at last we will deal the molecular mass related problems on these polymers. Okay children, thank you. In the next class we shall see these topics. In the meanwhile, you please read the examples concentrating on each side heading. Okay, thank you.